Hey guys, in this lesson we're going to practice switching from exponential form like this to radical form, which is going to look like this. And we're also going to practice switching from radical form to exponential form. And depending on how long that takes, I might go ahead and include rationalizing the denominator in this video. Alright, but before we get started, let's go over the homework protocol. Guys, I want you to do the assignment by yourself as best you can before you watch this video. Then check your answers using the answer key posted on Edmodo. Again, before you watch this video, check your answers. Watch the video for the problems that you got wrong or could not complete. But this is important, no copying. Redo the ones you got wrong by yourself. At no point should you have a pencil in your hand while you're watching the video. You will learn very little if you just copy off the video. Okay, write each expression in radical form. Well, 1/2 power is the same thing as the square root. Okay, so this will just be the square root of 7. Alright, there's an invisible 2 right there anytime you have the square root, but we don't write it. Okay, number 2. Now this has both parts. Now just understand, anytime you see a fractional exponent, the numerator is the power and the denominator is the root. Alright, it's always in the form power over root. So let's start with the root of 3. So we know this is going to be the cube root, and then we'll have our 4. Now we're supposed to have the 4th power. You can either put that on the inside like this, or I could have done it like this with, I'm sorry, that was 4th power. With the 4th power on the outside. Okay, but I'm going to do it like this. Alright, number 3. Same thing, power over root. So 3 is the root. Let's start with that. So that's cube root of 2. And then 5 is the power. So put that as the exponent. Okay, take a look at number 4. Power over root. The root is 3. Start with that. Cube root of 7. And then 4 is the power. So 4th power. Okay, number 5. Power over root. The second root is the square root, and we will not write the little 2 right there. It's understood. Alright, do not put the 2. So then it'll be the square root of 6, and the power is 3, so the 3rd power. And number 6, power over root. The root is the 6th root. Alright, so we'll do the 6th root of 2. And the power of 1, we're not going to write that little power of 1. So the 1/6 power is the same thing as the 6th root. We don't write any exponent in there. Alright, for the next few problems we are going in the other direction. We're given a radical expression, and we're going to rewrite it with a fractional exponent. Now, if we keep in mind that when we make our fractional exponent, it will be in the form power over root. If you keep that in mind, then let's see. So you know I'm going to have 10. 3 is a power, so that'll go up in my numerator. So it's just a matter of what's the root. Please do not put a 1 right here. Like I mentioned above, when there's no index showing, it's the square root, the second root. It's an invisible 2. So this will be 3 over 2, not 1. That's a common mistake. Number 8. Okay, 6 is definitely the root. Okay, we need to do power over root. So since 6 is the root, it'll be in the denominator. There is no power showing, you know, so it's sort of like having a power of 1. So yeah, the 6th root is the same thing as 1/6 power. Nice and simple. Okay, number 9. Alright, here we have the power and the root showing. Just remember, power over root. Alright, now if it sounds like I'm repeating power over root over and over and over again, I'm doing that on purpose. I'm trying to brainwash you into never forgetting that. I'm going to say it 3 more times in a row right now. Power over root. Power over root. Yeah, that's right. Power over root. Okay, so number 10. Power over root. 5th power, 4th root. This is muy fácil, no? Fácil means easy in Spanish. Bonus material for you. Alright, cube root is the same thing as the 1/3 power. Okay, and you can still think of it as power over root if you visualize this invisible power of 1 and then the root of 3. But I prefer you just understand that cube root is 1/3 power, square root is 1/2 power, 4th root is 1/4 power. Fácil. Okay, so like I said, 6th root is 1/6 power. It's immediate. I don't really want you to have to go, oh, that's a 1 is the power and the root is 6 and so it's 1/6. No, 6th root, 1/6 power. Get fluent, people. Alright, that's less than 7 minutes, so I'm going to keep going. Rationalizing the denominator. Alright, it's going to be different depending on whether we have a square root or a cube root or a 4th root, etc. But hopefully you have learned previously a fun pattern. If I were to do radical 2 times radical 2, well, that would be the same thing as the square root of 4, which is 2. Radical 3 times radical 3, that's the square root of 9, which is 3. Radical 4 times radical 4, that would be radical 16, which is 4. So hopefully you can see the pattern and you can get comfortable enough to skip the middle step. Okay, radical 2 times radical 2 is 2. Radical 3 times radical 3 is 3. Radical 4 times radical 4 is 4. That way you can do things that are crazy big, like the square root of 1,421 times the square root of 1,421. I don't know what 1,421 times 1,421 is, but if I multiply this together, I know I'm going to get 1,421 as the result. So why did I just hurt your ears with that whole explanation? That is a tool that we can use, rationalizing the denominator. This is an irrational number, so rationalizing it means turning it into a rational number, no more radical. So like you just observed, if I were to multiply this by itself, there would be no more radical. Okay, because we just learned that radical 3 times radical 3 is just 3. So great, the denominator is rationalized. Unfortunately, I just changed the value of the problem by just multiplying the denominator. But I can balance that out by multiplying the numerator as well. That way I'm really multiplying by radical 3 over radical 3, which is 1. Multiplying by 1 changes nothing, so it is legal. So in the numerator, I will have negative 5 radical 3. Kabam! Okay, that's how you rationalize the denominator. What do you think I'm going to do right here? Yeah, that's right. I'm going to multiply the denominator by itself. Got to do the numerator too. Okay, radical 7 times radical 7 is 7. Now up here I've got this 5, I'm just copying that down. Radical 2 times radical 7 is radical 14. That will be the answer to number 14. Okay. Alright, now this is switching gears. Hold on, let me pause for a second. Alright, this video is a little short, but I'm going to stop this video here, and we'll continue this lesson on another video. So on the next video, we'll learn how to simplify exponential expressions like these, okay, with negative exponents and everything. And in the next video, we will learn how to add and subtract these types of radical expressions as we simplify as we go. And multiply. Yeah, great. Hope this was helpful. I will see you on the next video.